sets. So what did we say? What is set? What is set? We discussed that, right? Tell me, what is set?
It's an inordered thing. Which it's an inordered non-mutable collection, right?
No, it is also mutable. Okay, set is also mutable. So unordered mutable collection. So it is like your list, but there's no order to it. Okay, so I can define a set like this. Now we have used square bracket for list, we have used simple bracket for tuple, and we have already used flower bracket for dictionary, isn't it? Right? Now flower bracket is also used for creating set. Now, if you're declaring an MC set like this, and if so we did same thing for dictionary, right? So empty flower bracket will always be dictionary only. Empty flower bracket will always be dictionary. Okay, if you add a member to it and this member does not have colon, it means it's a set. Okay, so if you have empty curly bracket, it will read it as a dictionary only. But when you start adding members to it, okay, and it sees that, okay, there is no colon here, it means it is a set, right? And you can add multiple values, right? I told you there is no order, so you cannot do indexing here. You cannot say set of 0, set of 1. You cannot say that. Okay. If you want to add a member to set, so you will say set1 dot add. And let's say I add 22. And now when you print it, print set1, you will get 22 at the end. Okay. I told you it's unordered, so you cannot say at the end. Okay. It can be added anywhere. Do you see? The way we added and the way it is displaying is totally different. Okay. It will be different. Okay. You cannot trust the order of a set. We have already discussed enough on that, right? Why the order is not important, or order is not that important for a set. Okay, because it is used to just represent the value, and when you're representing, doesn't matter which order you represent. Okay, now again, since it is mutable, this also has your deep and shallow copy, right? So deep and shallow copy that we discussed in list and dictionary also is true for set. So if I say here set2 equal to set1, and I say set3 equal to set1 dot copy, right? So these are two ways to copy, right? This will also create a duplicate copy of set1. This will also create duplicate copy of set1, right? So if you want to print it, you can actually print it. Print printing 1, and then I'm going to say print set1 slash set1, right? And I'm going to do it for set 2 and 3. I'll say set 3, I'll say set 2, and here I'll say set 2, I'll say set 3. And when you run it, all these three will have same set of values, correct? Because we created a copy. But now let's say we add a member to set 2. Okay, I'm going to copy this entire thing and I'm going to paste it here, printing 2. And I say now set2 dot add and 25. Okay, set2 dot add, okay, say 29. Now what will happen when I run this? Okay, we added 29 and 25 in set 2. So 29 and 25 is present in set 2, which is expected. But set 1 also has it. and set 3 doesn't have it. Why is that so?
We are taking equal to so set 2 equal to set 1.
Correct. When you
And
say, yeah,
in the set
go
3,
ahead.
we are just copying.
Right. Right. So what is that copying called?
Before adding the element, just it copies into the set 3. After it is
No, no,
adding
no.
set
What
in
is
the
that
set.
called? What is that called?
Deep copy, shallow copy.
Yes. Which is deep copy, which is shallow copy?
Assigning equal to is deep copy and dot copy is shallow copy. Copy function itself is shallow copy, right?
Correct. Copy is shallow copy. Yes. Okay. So this is called shallow copy. Okay. As I said, remember it like a photocopy machine. It will create a duplicate copy. Okay. This is your deep copy. That means both set 2 and set 1 will point to same location in memory. You can use what is called ID. Okay. If you want to see the ID of set 1, set 2, you can see the ID. Okay. So I'm going to say ID of set 1, ID of set 2, ID of set 3. And when you run it, see, ID of set 1 and set 2 is exactly same. Yes, they are same because they are same. Though we have two different variable names, okay, though they are two different variable names, but they are actually pointing to the same value. So whatever you do with set 1 will also get reflected in set 2. Whatever you do with set 2, set 1 will also show you that. Okay. But set 3 is creating duplicate copy and it move on, right? So the moment you create a copy, it is a duplicate copy. But after that, there is no connection between them. Okay. Yes. Okay. Let's see now different operations that are there in set. Okay. What are different operations that you know of in set? Union, correct? Intersection, correct? What else? Difference and symmetric difference. Okay. So let's see what each of these things mean and then how to implement this in Python. So do you see MS Paint here on my screen? So let's say first I create a set 1. This is your set 1, right? Now you create set 2, right? So this is a set 1 and this is a set 2. So when you say union, what does that mean? It means select everything, right? It means this one also, this one also, this one also, correct? This is called your union. Okay, union means, okay, you are combining and taking all the data. Okay, so going back to the example that we were discussing day before yesterday, if I tell you that we have, I asked student, right, name 5 fruits. So, someone answered me, A, B, C, D, E, and another student answered me C, D, E, F, G. So how many total fruits I've got as answers? It is not 5 plus 5, 10. Okay, it is A, B, C, D, E, and C, D, E is common anyway. So till now I have not got more. F, G. So I've got total 7, right? 5 from here, 5 from here. Okay. Maximum value that I can get is 10 if there is no overlap. If there is no overlap, I can get 10. But there's overlaps. Overlap you'll not count twice, you'll count only one. So, okay, when you perform union, and if you have number of elements as 5 in one, 5 in another, maximum value that you can get in union is 10, where both the sets are disjoint. Okay, so if you have set, okay, like this, okay, let's not use yellow, let's use black only. So you have one set like this and another set like this. Okay, they are together, but they're not connected. We call them disjoint set. So if you perform union here, okay, so you'll get 5 plus 5. Third scenario is where you have set and both the student has named same, both have named same 5 values, A, B, C, D, E, A, B, C, D, E. So in this case, your union, okay, union is going to be 5 only. Is it not? Because both have named same 5. So you have got only 5 values. So when you perform union, the number of elements in union can range is from lowest, which is 5, to maximum 10. 10 is the sum of elements of both the set. And this is very much used, based on, they'll tell you that, there are 5 players who plays cricket and 10 players who plays football. There are 3 players which plays both. How many players are there? Right? So 20 plays football, 5 plays cricket. Okay. So maximum people that you can have is 25. And minimum you'll have is 20. So how many players are there? So the answer would be somewhere between 20 and 25. It can't be less than 20. It can't be more than 25. And it says that 3 of them plays both football and cricket. So 3 is common. Only 2 is different. So 20 plus 2, 22. There are 22 players. Okay. This will help you to solve such problems. Did you understand what I said? If no, you stop me. Okay. Okay. So this is your union. Now, if you talk about intersection, so again, let's take this set and another set. Okay, this is another set. Intersection means common. Okay, which will be your this part. This is intersection, isn't it? So if I have to write it, this is your intersection. Intersection. Intersection is the common element between 2 sets. Okay. Now we'll talk about difference. Let's say you have, I'll use black color itself. So let's say you have one set and you have another set. Okay. I'm saying, now this is A, okay? We call it as A. And this is your B. I'm saying A minus B. Okay, A minus B. A minus B means from A, remove B. From A, remove B. Okay, I have banana and mango with me. Okay, I have banana and mango with me. You are saying give away banana and cherry. I have banana and mango. You're asking me to give away banana and cherry. So cherry I don't have. I can't give away cherry, right? So what will I give away? Only banana I'll give away. Correct? So if this is your A, okay, And I'm saying from A, remove B. So from A, you're removing B. Okay. So since, okay. So when you're removing B, this is common between A and B. This will be deleted. I have no control. This extra part is not in A. So this will not have any impact. So A minus B is going to be just this part. Agreed? Okay. I'm saying from A, remove B. So what is there in B and A common will be removed. The rest, I don't have it. How can you take it away? Right? You can't take it away what you don't have, what I don't have. Yes or no? All three of you are silent,
Yes.
right? Similarly, your A and B will be different. Sorry, A minus B is different than B minus A. Okay, so if I have to do B minus A, let's draw another set here. So I say, okay, this is your one set, and this is your another set, right? So this is what we call as A, and this is your B, right? Now if I say B minus A, okay, I'm saying from B, remove A. This entire thing is B. From entire thing, take out A. Okay, take out A. So what do you get? You get only this, right? I will fill the inside thing, not the outside. Okay, so this is what you get, B minus A. So B is there, from that you're removing A. So, remember the Apple picture, right? Apple logo, that is like, Apple minus something else, that's gone. This is your difference, or we call them as minus. Okay, this is difference. This is how you calculate difference in set. Difference. You have one more concept called symmetric difference. Okay, we say symmetric difference. Okay, now symmetric difference is, again, it's a difference only, right? But you are removing from A minus B and B minus A. You're doing both A minus B and B minus A. That's so called symmetric. Okay, symmetric difference AB is like A minus B and B minus A. Okay, so you'll get something like, this is your A and this is your B, right? So A minus B is going to be this one and this one. No common part. This is symmetric difference. Of course, this is your A. So this is your A. A, and this is B. Symmetric difference A minus B is this. So symmetric difference A minus B, B minus A will be same, right? But difference will be different. Any questions so far? Okay. Now let's go back to our PyCharm and see how these are implemented, right? So I'm going to go back to my
Once
PyCharm.
explain the symmetric difference, this middle one.
Okay. Symmetric difference is A minus B. So A minus B will give you this part, isn't it? This part, right? And B minus A will give you this part. And you join them together. So this common part is not there. Understood?
That is symmetric difference.
That is symmetric difference.
So
So you
how will
perform A minus B and you perform B minus A, put them together.
together means addition, sir. To A minus B plus B minus
Union,
A.
union, union.
Union. Okay.
Right? Together means always union.
Okay.
Or if you don't want to do minus, don't do minus, just perform union and remove the intersection part.
Okay.
Right? So union minus intersection is your symmetric difference.
Common elements will not be considered.
Common elements are not considered. Exactly. Those are deleted. Those are removed. Okay. So that's what it is called symmetric difference. Okay. So now we'll go back and we'll try to implement using our Python. So I'm going to say define here. You already have set, right? This is your, okay, let's take set 2 and 3. Okay. We'll copy it so that we don't have to type it again, right? So I'm going to say equal to set 2, set 3 equal to. And let me add some different numbers here, 31, 35. Okay, so first thing is performing union. Union, there are two ways to perform union. You can say set 2 dot union set 3. Or you can even say print set 2, okay, this pipe symbol, straight line pipe symbol, which is above your enter keyword. Pipe, we call them as pipe sign. Set 2 pipe set 3. Okay, so you can use a method union to do that, or you can use an operator to do that. So this pipe sign is also called as set operator, okay, which is you performing union. So when you run this, you see, you get same answer. Union means what? Combine all of them together. So you have 1, 25, 22, 9, 10 common, and then 29, 35, 31, 35 all together you get union. Make sense? Okay. Similarly, you have other functions as well. Okay. This will do for intersection. This will do for difference. This will do for symmetric difference. Let's go back and change it. Union done, intersection, right? Intersection. Intersection is done using ampersand sign here. Okay. So this is your union and this is your intersection. Intersection means common elements. So these are the common elements. Now we'll do set to difference. Okay. Or you can put minus sign here. Okay. Set 2 minus set 3. Or let's do here. Let's do set 3 minus set 2 to see how they are different. Okay. So they'll be different, of course. Right. So this is your 25, 29 is set 2 minus set 3, and 35, 31 is set 3 minus set 2. Okay. And then we spoke about symmetric difference. Symmetric difference. And this is done using this upward key. You see, the hat we call it, right? In mathematics, the shift 6. 6 keyword has this sign, upward arrow. So this is used for symmetric difference. And when you run it, so it is symmetric difference. Symmetric difference is nothing but putting them together, right? The union of these two, isn't it? So 2 elements and 2 elements, you put them together, you get 4 elements, right? So that's your symmetric difference. Right? Now, each of this function also has update function, union update, intersection update, difference update, symmetric difference update. Okay. Now, all this that we have done, union, intersection, difference, symmetric difference, we are saying set to dot or set to, union set 3, set 2, intersection set 3. All of these is going to give us a new set value. The values in set 2 and set 3 does not change. Set 2 and set 3 will remain same. If I print it here, you will get same values that we gave here in the beginning, line of 25 and 26. Okay, but when you perform update, so answer is calculated. Let's say if you perform symmetric update, you'll get same answer, but set 2 will be updated. The one that you put here, right? Something dot. This set will be updated with this value. Did you understand? This will not give you a new set. It actually changes the existing set. Set 2 will change. Okay. So if you want set 2 to change, lose its old value and get new value, you use update. But if you do not want set values to get changed, then don't use update. Is it clear? So I can show you here. Let me run. I'll just copy this part, right? Set 2 and set 3. So if you see, we have done all these, but still values of set 2 and set 3. Oh, this is not ID. Copied the wrong one. Okay, so this is what we gave here, right? Now, where is 30, 31, 35? Something is wrong. 33 and 35 did not get added. Are we using set 3? Yes, right? 31 is here. Oh, this is capital S, right? So you have to be careful, okay? It's case sensitive. Okay, now you see 31, 35 in set 3. 31 here, 35 here. So these are the values that we use in set 2, set 3. And these values of set 2, set 3 did not get changed after performing all those operations because of answer was given as a new value. But if you do update, whatever update you do, right? Okay, if I do symmetric update, okay, now if you print set 2 and set 3 will remain same and set 2 will have different value. Okay, none is printing because this is not returning any new value. This is not returning any new value. That's why you get none here. But here you see, okay, makes sense. So this is how set works. Yes.